So today we'll continue with this discussion on synchronous decade counters design. So what is a decade counter? Decade counter, what is the modulus of a decade counter? What is meant by modulus of a decade counter? What is the modulus of a decade counter? 10. So the first state is 0 and the last state is so binary, you'll say 0 0 0 0 and the last state is 1 0 1 0 or 1 0 0 1. Last state is 1 0 0 1 because with the 1 0 1 0 this will make it 11 states. Okay, so 0 to 9 0 is always considered as a state because it is a state. So this is the design. We'll first as usual I want you to draw the state diagram for this decade counter. Now before that we'll just mention two things. One is that we'll study two methods to design this synchronous decade counters, but we'll just follow the first method in our classes, as well as for the exam point of view we'll just follow this first method, and we'll study the second method mentioned here. That's mentioned because I saw it in one or two textbooks as well as online forums. So just for the sake of that we discuss it here. There is a very good text by Thomas Floyd. We used to refer to this text, I think 5th edition our times. So now it's 11th edition. It's a good book. You can refer those texts. So I think Google Books has shared a couple of pages of that. You could refer that. You could search online for versions of this. You could make a try to go through this text if you have. So it's a good text, equally good like Morris Manu. So that text makes a design like that. You don't have this first method design here in this text. So the first method does not make any assumption that J equals K. For the flip-flop inputs, you don't make any assumption that they are equal. You would design separately for the K maps, for J1, K1, all those things. Starting with it's a 4-bit counter. So J3, K3, J2, K2, J1, K1 and J0, K0. You will separately design for each of these, and whatever logic you get after minimization using K-map you will implement. Now the second method, however, just assumes that this inputs J3 equals K3, J2 equals K2, J1 equals K1 and J0 equals K0, and it makes a design. So rather than having 8 K maps as in the first case, you will only have 4 K maps, 4 Karnaugh maps. Okay, so that's it. The design is simpler, but it's not a conventional way to design it. Then we'll also design decade counter based which has lockout protection. What is lockout protection is that say you have in a decade counter you have 0 to 9 binary states, and the states from 1010 to 1111, that is 15, they are unused. Now say when you turn on you have designed a counter and you then power it on, then the counter, you expect the counter to be in any of these valid states, that is in the 0 to 9 states, but it might not be always the same. So it might be in some invalid state. So you haven't told the state machine, that is a counter in this case, what to do if the counter lands up in an invalid state. So it is locked out in that state. It doesn't know what to do. It will just be in this state. It might jump from one invalid state Maybe accidentally it might even reach a valid state, but you are not sure. Your design doesn't involve any you haven't factored that in your design. So lockout protection, that means you need to prevent lockout. So we'll decide decade counters with lockout protection. So this will be, we'll follow the method 1, purely method 1 for rest of the designs. You might also have sequence generators. Say later on you'll generate sequence generators. For instance, you want to generate only the odd number terms, say 1, 3, 5, 7, like that, or the even numbers terms 2, 4, 6, 8, or any other mix of these random sequence, so which repeats. All those cases we'll be using the design with the lockout protection, so that any invalid state, what you do, you will recycle it to a valid state, either initial state or any valid state. You'll recycle it like that. That will be the approach. So we'll just straight away proceed with the design. So I have this I hope you have drawn the state diagram. Now draw the state table, write down the state table. So it's a 4-bit counter. So this is 0, 0, 0, 0, then the next state, the present state, next state 1, the present state 1 means the next state will be 2, present state 2, the next state is 3, present state 3, next state will be 4, and so on. So, and when you reach present state 9, the next state is 0, that is the initial state. So this is the assumption view. So we have not considered the things beyond. Okay, we are not factored in the things which are beyond this. The invalid state now. We'll consider the invalid state later. As of now, we'll assume those invalid states as don't care. That will be the approach. Those invalid states. So that is the states from 1010 to 1111. We'll assume that as don't care in our K-map, and we'll design like that. Okay, right. So write down the state table. Have you written down the state table? I thought you would have completed the half the design also, because I have already told you how to design this thing. Yes means what? Yes. You have completed the design halfway. State diagram varachu, right? You wrote the state diagram. You drew the state diagram. So write down the state table from the state diagram. So from the exam point of view, you will need all these things in your paper. Only then, because each of these will have a new value. This you will have a scheme of valuation where it might, for instance, if this is for 10 marks, say I'll just tell you how some things work. So you'll say state the mark split up might be like this: state diagram 1 mark, state table 1 mark, then the completed state table. That's what. They'll give it as 3 marks, or maybe even 2 marks. So that makes it 2 plus 1 is 3. Then remaining 7 marks. 7 marks. Say 6 marks might go for the, or 5 marks might go for the K-maps, and then 1 mark for the 2 marks might go for the logic diagram. That will be the split up. So you need all these things there in your paper so that you will get the mark. Okay, so that's the idea there. Okay, so okay, so this is the state table, completed state table. So I want you to just draw this thing. We have skipped a step in between. That is, after this you can, for your reference, you can draw what do you say, excitation table of the flip-flop, that is the JK flip-flop in this case, on some corner of your paper, so that you can refer that and fill up the state table fully with the flip-flop inputs. Okay, so I'll just randomly ask people to send me the design. WhatsApp ചെയ്യാൻ വേണ്ടി പറയും. You know my WhatsApp number. So this is WhatsApp and phone, both are the same number. So this is my phone number. I'll ask people to send me the design. Okay. Notebook ഒക്കെ ഉണ്ടല്ലോ എല്ലാവർക്കും. So we are here. So we have the flip-flop inputs as already mentioned. How to, hope you have got the same thing. You have got the same. I want you to verify, cross-check you have got the same thing. I have made it, checked it twice. I got a correct design as well. That's what I assume. You just check whether any errors, please, if there are any errors, you may point it out. Go to the next step. Next step is you will draw the K-map. This is for J3. Yeah, J3, K3, J3. This is for J3. K3 will come. J3. Fill up you will use this as a reference. 000 the present state വെച്ചിട്ടാണ് നമ്മൾ K-map fill ചെയ്യുന്നത്. Present state in the values ആണ് cell identify ചെയ്യാൻ വേണ്ടി നമ്മൾ ഉപയോഗിക്കുന്നത് കേട്ടോ. The cells in the K-map. So if I want you to recollect how we divide a box. I told you those things. Okay. K-map fill ചെയ്യണേ. K-map, fill in the K-maps. ഇതിൻ്റെ എക്സ്പ്രഷൻ എന്ത് വരും? ഇതിപ്പോൾ this comes as Q2 and what? Q2 and Q1 Q0. So that is Q2 Q1 Q0. Yeah, this is Q1. Okay, this is Q1 Q2 Q1 Q0. Right, this is Q2 Q1 Q0. Right, I have referred it as Q2 again. This is Q1. Right, Q2 Q1 Q0. It's a typo. Then for J, same error will come there. No, for K3 design G. Yes, design G. സാധാരണ ഇത് ഓർഡറിലാണ് പറയുന്നത്. Q2 Q1 Q0. You'll write in a definite order. Okay, yes, Q2 Q1 Q0 ആ ഓർഡറിൽ തന്നെ പറയുന്നത് കേട്ടോ. അതങ്ങനെ തന്നെ എഴുതുകയാണ്. It's there, natural way of doing that. For J3 K3 you will have a design like this, and you will bump off these two terms. That is, this will go, that is, this is Q1 not Q1 Q0. Right, Q0 How come there is an error there? Right, I'll just have these four terms. There is an error. Let me see. You fill in the K-map. So that is K3 is Q0, J3 is Q2 Q1 Q0. So I had a real-time edit in this. That is the advantage of tech. I'll just vary it. So error was noticed now, even though it was I had designed on paper, so when I transferred it to the slides there was an error, right? It's a typo. Then the K3, then K1 means K2, right? This is J2 K2, that is for the designs. Then in the term Q1 Q0, Q1 Q0, right? This is Q1 Q0, and again K2 is again Q1 Q0, right? And K1 J1 comes as Q3 bar and Q3 bar Q0, Q3 bar Q0, Q3 bar Q0, and finally you have K1, that is K1 is Q0. Yes, K1 is Q0. K1 is Q0. Again, same as earlier case. K3 and K1 both are Q0. And finally, for the J0, K0 inputs, J0, K0, that is, this is 1 and K0 is also 1, right? So summary, this is the summary of whatever that is J3 is J1 is still written incorrectly, that's what J3 K3 is Q0, that is what I'll just correct it. I think you are continuing with the design. You are designing, okay? Design cheyale. So this is the thing. So that is right. So this is the design. This is the final. Are you getting this design? Yes, no. Yes, how many people have got this design? Right. So now just draw the thing. Draw the circuit, so that completes your K-map design. That completes your design for the synchronous decade counter, right? That's it. So draw the logic diagram. I haven't drawn the logic diagram. I want you to draw the logic diagram because I couldn't get a good tool to draw this thing. KiCad I tried, so you just draw the thing according to this whatever logic is given here. So just draw the thing, and that's the thing. So you draw the logic diagram. We'll just discuss the next method 2 next day. Okay. So logic diagram varaikkanam. Now as a class work or homework, whatever you call it, I want you to design mode 12 counter, mode 12 counter, right? Mode 12. So with JK flip-flops. ഇനി ഡി ഫ്ലിപ്പ് ഫ്ലോപ്പും വേണമെങ്കിൽ ചെയ്ത് നോക്കും. ഇന്നിപ്പോൾ ഒരു അവറൊക്കെ ഫ്രീ അല്ലേ, ഇപ്പം കുത്തിയിരുന്ന് ചെയ്ത് കഴിഞ്ഞാൽ ഒരു അരമണിക്കൂർ കൊണ്ട് തീരും കേട്ടോ. So mode 12 counter with the JK flip-flop, that will give you hands-on. I'll just post the same question in the classroom as well. So because only 53 people have joined the class, so I won't be checking the homework